This is going to be your first video for your trig unit, and we're going to start by reviewing our SOHCAHTOA. This is something that you learned in geometry. If you remember, SOHCAHTOA stands for sine is the opposite over the hypotenuse. Your cosine is adjacent over hypotenuse. And your TOA is tangent was opposite over adjacent. So those three are reviewed. Then we've got some new ones. Cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. And this is your cosecant. We can also think, again, it's the reciprocal of sine, so it could also be 1 over sine of theta. Your secant is the reciprocal of cosine, so instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Again, we've got our secant there, which could also be seen as 1 over cosine of theta. And then last is your cotangent, reciprocal of tangent. So that's going to be adjacent over opposite, your cotangent, or 1 over tangent of theta. So let's go ahead and apply this. We've got our 3, 4, 5 triangle down here. If I want the sine of angle A, I find angle A, and sine is standing for opposite over hypotenuse. Remember, the hypotenuse is always the side opposite the 90-degree angle. So the side opposite of A is 4, and the hypotenuse of this triangle is 5. If I want cosine of A, I'm looking for adjacent over hypotenuse. So here's again my angle A. I want the side adjacent next to it, which is 3 over the hypotenuse of 5. Then we're going to go to tangent of B. So I find my angle B. Tangent is opposite over adjacent. So the opposite side is 3, the adjacent side is 4. So this is going to be 3 over 4. Those are our old trig functions, our SOHCAHTOA. Now to our new ones. We've got cosecant of B, and cosecant is hypotenuse over opposite. So we find angle B. We want the hypotenuse of the triangle, which is 5, over the opposite side. Opposite of B is going to be 3. So this is going to be 5 over 3. Then we want secant of A, and secant is going to be hypotenuse over adjacent. So we've got 5 on top again, that's our hypotenuse. The side adjacent to A is 3. So the cosecant of B and the secant of A happens to be the same ratio, because opposite of B is 3 and adjacent to A is 3. All right, our last one is cotangent of B. So we find our B. Cotangent is adjacent over opposite. The adjacent side is 4. The opposite side is 3. All right, the next thing on our notes for today is another review, a review of your special right triangles. You've got 2 special right patterns, a 45, 45, 90 triangle and a 30, 60, 90 triangle. In a 45, 45, 90 triangle, it's an isosceles triangle, so the legs are congruent, and those are both SS. The hypotenuse is whatever the S is, root 2. In your 30, 60, 90 triangle, across from your 30-degree angle is S, across from 60 is S root 3, and across from 90 is 2S. That's the pattern that you're going to follow for all special right triangles. So when I look at 30, look at my first triangle, I've got a 30 and 90, which means this has to be 60. The first thing I would do is label my pattern. So across from 30 is S, across from 60 is S root 3, across from 90 is 2S. This is the best situation we could have. We are given what S is equal to. So if S is 9, and this side is S root 3, that means that this is 9 root 3. Across from 90 is 2 times S. So we've got 2 times 9 which means that this side is going to be 18. Then we've got our 45, 45, 90 triangle. Even though it's not labeled as 45, 45, we know that it's an isosceles triangle because your legs are congruent, which means the two remaining angles are split evenly. We know a triangle is 180 minus 90 means you have 90 left, cut in half. So we label our pattern. The two legs of your triangles are S's, and this is whatever your side is, root 2. Again, best case scenario, we're given what S is. These are congruent, so that means that this is also 10, and this is going to be 10 root 2. All right, for the next part of your notes, you need your calculator. So we're going to talk about how we can do these trig functions on our calculator. The first thing that you want to do is make sure that your calculator is in degree mode. So we go to our calculator. Here's your mode button. When you hit mode, we want to make sure that degree is highlighted. So mine is radian, so I've got to change it out of radian mode into degree mode. So I highlight degree, I hit enter, and it changes my mode into degree. So you want to make sure that your degree is highlighted. And when you enter in a trig function, it's always whatever your trig function is, sine, cosine, tangent, cosecant, secant, cotangent of your angle measure. And then that's equal to whatever your side is over your side. So in this case, I've got sine of x is equal to 12 over 13. Because I don't know what x is, that means I'm solving for an angle. And this is another review from geometry. If I'm solving for an angle, that means I need inverse trig. So when I go to my calculator, I'm not going to use the sine button. I'm going to need to use the inverse of sine. And on your button, that's sine to the negative first power. So x is going to be equal to inverse sine of that ratio that you were given, 12 over 13. So we go to our calculator. You see the sine button, cosine, tangent. Well, right above sine is sine to the negative first. So I want to get to that sine to the negative first. So I hit second sine, type in my ratio, hit enter, and we're going to round to the nearest hundredths for now. So x is going to be equal to 67.38 degrees. For now, we're only going to be dealing with degrees. Later on, we're going to start talking about radians. When we go to our second one, we've got the cosine of 47. So remember, 47 is your angle measure, is equal to x over 10. Here's my x. That means I'm going to be solving for a side length. And if I'm solving for a sine, then I use my regular button, sine, cosine, tangent. But I want to get x by itself. You can look at this as a proportion. So if you cross multiply, you get x is equal to 10 times the cosine of 47. So we go ahead and enter that into our calculator. 10 times the cosine of 47. And again, we want to make sure we have our calculator in degree mode, which we know we do because we just entered that in. So we get that our side length is going to be about 6.82. So as you approach a problem, you want to ask yourself, am I solving for an angle or am I solving for a side? That will determine whether you're using the regular trig function or the inverse trig function. And if you go back, it's always the trig function of the angle is equal to your ratio of sides. So in this case, once again, we're solving for a side. We have that our angle measure is equal to 33. As I said before, we can look at it like a ratio. So we have y times the tangent of 33 is equal to 7. I want y by itself, so I divide both sides by tangent of 33. So we've got y is equal to 7 divided by the tangent of 33. We enter that into our calculator. Make sure that you're following along with your calculator so that you know what calculator strokes that you need to use come quiz test time. And we get that our missing side length, our y, is going to be about 10.78. Okay, so let's go ahead and look at the back side of our notes. Solving for a triangle. When you are solving for a triangle, you have 3 sides and 3 angles. So you're always going to have 6 pieces of information. Oops. Again, 3 sides. So we've got side A, side B, side C, and then we have angle A, angle B, angle C. If you notice from the diagram, side A is opposite or across from angle A. Side C is across from angle C, and side B is across from angle B. When you are doing this, you always want to use exact values or given values as much as possible. Use exact or given values as much as possible. If you use rounded values, your answers are going to be off. So when we look at our first example, we are given our right angle. We have side B is 3, side C is 7, and we want to find all of our other missing information. So when we look at this, there's a lot of different ways we can go about it. I'm going to go ahead and start with side A. Another review is if you're given 2 sides of a right triangle, we can always solve using Pythagorean theorem. So a squared plus b squared is equal to c squared. We get a squared is equal to 40. Square root, I could ask you for the exact or the rounded answer. We know using our factor tree that this is going to become a is either 2 root 10 as your exact answer, or your rounded answer is it's going to be about 6.32. So it just all depends on what I ask for. We have our side A. We're not going to use that as much as possible because I want to use the values given to me. So I have all 3 side lengths now. Now I want to find my 2 missing angles. I need angle A and I need angle B. Well, when I look at angle A, I have side length 3, which is adjacent, and my hypotenuse. So I think to myself, which trig function involves adjacent and a hypotenuse? That would be your cosine. So the cosine of my angle A is that adjacent side of 3 over the hypotenuse of 7. This tells me that I'm going to be solving for my angle measure. So I'm going to use my inverse cosine. And you remember from before, you have that button, so you use second sine. And that's going to tell me that my angle A is going to be about 64.62 degrees. I only have one more piece of information left. I need to find my angle B, and angle B is up here. So this time I have 3 and 7 still, but 3 is opposite B, 7 is the hypotenuse, which means that's cosine. So cosine of angle B is going to be equal to the opposite, which is 3, over the hypotenuse. Once again, I'm solving for my angle, so I'm going to use the inverse sine and find that my angle B is going to be about 25.38 degrees. That is one way you could have done it. You could have also remembered that in trig, all 3 angles add up to 180. So 180 minus the 90 that you were given, minus the 64.68 that we had from angle A, and you can subtract to find that same answer of 25.38 degrees for angle B. All right, you have a second triangle. What I want you to do now is press pause and see if you can do the second triangle by yourself. Remember, you always have 6 pieces of information. You want to find the information that you do not know yet. So make sure that you hit pause now and try these on your own. Press play once you're done. All right, let's see how you did. First, Sometimes we make things more complicated than they have to be. For angle B, if you're given 2 of the 3 angles, just subtract from 180, and we find that angle B is 55. We're going to, again, use the values that were given to us. So when I'm looking for side A, I'm going to use the fact that I have a 35-degree angle and a measure of 10 for the side. So for angle A, side A is opposite hypotenuse. Opposite over hypotenuse means that we're using our sine function. For side B, that's adjacent to the angle A that I was given on the hypotenuse, so that's going to be cosine of 35 is equal to B over 10. There's your setups, cross multiply to solve, and then we're using our regular sine, regular cosine because we're solving for a side length. Moving on to our last question, our application question. We want to round our answer to the nearest tenth, give it our directions. So a tree is casting a shadow on the ground that is 50 feet long. The angle of elevation from the end of the shadow to the top of the tree is 53 degrees. How tall is the tree? All right, so the most important thing here is getting your diagram set up. So if we want to visualize this, we've got our fantastic tree there. So it says that the tree is casting a 50-foot shadow. So our 50 is going to go here. Angle of elevation is going to be this angle right here. Remember, angle of elevation is your angle looking up, angle of depression is your angle looking down. So if I wanted angle of depression from the tree, this would have been my angle of depression. But I'm looking at my angle going up, so that's my angle of elevation, and I want to find out how tall the tree is. That's going to be your right angle. Always set up your diagram. So when we look here, I have the 53 degree angle, the 50, and the x. This is opposite, this is adjacent. Opposite and adjacent is going to be tangent. Tangent of 53 is x over 50. So x is going to be equal to 50 times the tangent of 53 degrees. We're solving for our side length, so we use our regular tangent function, which is going to give us 66.4 feet. There are other ways. We could have found this angle measure by doing 180 minus 90 minus 53, giving us 37 degrees if you prefer it that way. Then doing your opposite over adjacent, giving your setup as tangent of 37 is equal to 50 over x. This time, x would have been 50 divided by tangent of 37, but it's going to end up giving you the exact same answer. So no, there's always, most of the time, several different approaches that you can take to your trig function. All right, and that is it for your first flipped trig video for this unit.